We learned about spanning tree protocol. In that, what we learned is whenever you got a redundant path, the chances of forming loop. To prevent loop, spanning tree will block one of the port so that loop cannot occur. So spanning tree protocol is good, it prevents loop, but at the same time, it is also bad. Why? I'm unable to utilize both the links. This link is a standby link. This is the only active link. So whenever you got redundant paths, only one path will be active. All other paths will be standby, which is loss. Which is a loss. You see, this is 100 meg fast Ethernet FA. FA means fast Ethernet. This is 100 meg bandwidth link. This is another 100 meg bandwidth link. Now, both these links, if they are in use, then you will get 200 meg, double the speed, but you're not allowed to use that. Why? Spanning tree has blocked it. Because of this block, your half of the resource is gone. Need to do something. Spanning tree is good. It prevents loop. But in this scenario, when I want to utilize the maximum bandwidth, I'm not allowed to use. I have to sacrifice. We need to compromise. In order to provide a loop-free layer 2 network, we need to sacrifice half of the resource. There is a solution. And the solution is called as port channel. There's also another name for this. Ether channel. Ether channel, port channel. Both are same. What is this? We are going to aggregate both the links. We are going to aggregate these two links so that the switch will think that I got only one link. Hope you understand what I am saying. The ரெண்டு லிங்கையும் ஒரு லிங்கை போல இணைக்கும் பொழுது switch ஒரு லிங்க் என்று கருதும். உண்மையிலேயே அது ஒரு லிங்க் அல்ல, இரண்டு லிங்க் இருந்தாலும் according to the switch it is only one link. A kind of virtualization we do here. Virtualization is not only taking one device and subdividing or slicing it into multiple devices. It is also taking two devices and combining as one device. Here, two links are combined as one link. This is the hardware virtualization. This is also a virtualization. ஒரு கம்ப்யூட்டர்ல நிறைய விஎம்ஸ் கிரியேட் பண்றது ஒரு வகையான வெர்ச்சுவலைசேஷன். ஒரு பிசிக்கல் கம்ப்யூட்டர்ல நிறைய வெர்ச்சுவல் கம்ப்யூட்டர்ஸ். இன்னொரு வகையான வெர்ச்சுவலைசேஷன், ரெண்டு பிசிக்கல் கம்ப்யூட்டரை கூட ஒன்னா வெர்ச்சுவல் சுவிட்ச் மூலியமா இணைச்சு ஒரு கம்ப்யூட்டரை போல பயன்படுத்த முடியும். டிவிஎஸ், டிஸ்ட்ரிபியூட்டட் வெர்ச்சுவல் சுவிட்ச்னு சொல்லுவாங்க. அதை ESXi VMwareல சொல்லுவாங்க. So virtualization is done here. We take two ports of this switch, we combine and make it as one port. How many ports I can combine like this? 6. 6 ports can be bundled. Six ports can be combined, aggregated as one port, up to 6 ports. But there are some advanced device, like Nexus. They support up to 16 in a bundle. You can aggregate 16 ports. 16 ports. But active link will be 8. I do not want to get into such specification in this training. That's not now important. So let us first of all learn what is this port channel. As I said, it's an aggregation of link. It's a port virtualization. We combine multiple ports so that it can form a single virtual port. What is the advantage? Advantage is switch will see those two links as one single link and send the traffic by hashing and load balancing among both. Same way, the receiving switch also receives the hashed data on the other side from these two links. So there won't be a loop. There is no loop. There is no wastage of resource. You are able to utilize all 200 meg effectively. Port channel, which is also called as ether channel, which can also be called as port bundle, is aggregation of link. Now I have taken, you see here, two links. But if you go to the switch one, let me name this as switch B. If you see here, the name is changed to switch B. I can also double click and change here. Switch A and switch B. If you go and check in switch B, show spanning tree, you can see one link is blocking. Let me name it. How to name it? Config T, host name, switch. We also name switch A. So in this switch, all the ports are forwarding. So, but what is the use? The other end is blocking. So because of this block, you are now using only 100 meg. Each link is 100 meg. You're supposed to use 200 meg, but you are not allowed to use 200 meg because of the block. And the solution is aggregation. And you're going to see me doing it. Now, when you want to aggregate this, both the links should be same port type. Both can be an access port or both can be trunk port. One should not be access, another should not be trunk. Please pay attention. Both need to be same port type. Both can be access or both can be trunk. Let me make it as trunk. Interface range F0/1-2 switchboard mode trunk. Switchboard mode trunk. And I'm going to aggregate this too. After aggregating, please pay attention. After aggregating, I'll be using the same command show spanning tree. We should not see this two link. We should see a single link instead of this two. You should see one link. And the cost should be less. You see, for 100 meg, if the cost is 19, for 200 meg, it should be something less, isn't it? That's what we are going to verify. Now, right now I'm inside this two interface. I'm going to say channel group. Give any number. I'm giving 1. Mode on. I said channel group mode 1 on. I'll go to the other switch and I do the same. Interface range F0/1-2 switchboard mode trunk. Did I say trunk on the other side? Did I say trunk? Yes, I can see where it is. Come on. Yeah. Switchboard mode trunk is coming. Next is child group. 1. Same number you have to give. That's how I give 1. You need to give the same number because it uses this number to negotiate sometime. Not now. Later we'll talk about negotiation. Now, channel group 1 mode on. You can see that a virtual interface called port channel, and this one is the group ID that you gave. And there is a new interface coming up, you see. A new interface has come up. Now, if I go now and check this command, show spanning tree, look at this. How many interfaces you see? Only one. And you don't see F0, F01 or F02. Instead, you see port channel 1. So this port channel is bundle. It's not a single interface. It's a bundle. It's a bundle. You see? Type is shared type. It's a shared link. It's a virtual link. It's a bundle. Two links are shared together, combined together. And you see the cost was earlier 19, now it has gone to 12 because it's 200 meg. Earlier it was single link, separate, 100. It was 19, cost was 19. Now the cost is only 12. You see? So port channel helps to bundle. And you will not see any block. See, I'll go to switch B and show you. Show spanning tree. This is also forwarding. This is also forwarding. They are not blocking. They are not blocking. Both are forwarding. Now I would like to show you the members of this port channel. Show channel, show ether channel summary. This command will show you that the port channel has got these two members. What is that capital P means? It's a member of port channel. These two ports are in the bundle. And what is this capital S here? It's a layer 2. That bundle is not doing routing, it is doing switching. Layer 2. And what is the capital U here means? It is active. It is in use. It's not in a standby. It is not down. If it is capital D, then it is down. If it is I, then it is standalone. It is in use. The bundle is in use. The bundle number is 1. I was telling you, it creates a new interface. You can see that by typing this command, show interface brief. Show IP interface brief. You see, the interface which is created on behalf of this two physical interface is this. So these two physical interfaces combined as one virtual interface. And the cost of that virtual port, let's see that. Show, first of all, I want to show you fast internet. Show interface F0/1. If you see here the bandwidth, it's 100 meg. In kilobits, it is big number. If you convert that into megabit, you need to divide. So remove 3 zeros. You get in megabits. It's 100 meg. So what I'm going to do is, I'm going to show you the bandwidth of the bundle. Interface port channel 1. Now you can see here the bandwidth is twice the bandwidth of the physical interface because two physical interfaces being combined together. So what is the advantage of port channel? None of the ports are blocking. All the ports are green, meaning your resources are not wasted. Secondly, the network speed is getting increased because both the links are active. Your load is being shared with both. No wastage of bandwidth. Speed is now doubled. There is no active standby. Both are active. The advantages are many in this. You see, you don't need to compromise with the speed. You can keep adding more links. Instead of having 2 links, if you add 6 links, then you will get 600 meg. So more bandwidth. More bandwidth. Usually, it is needed actually. You see, we'll have like 20 computers, let's say. You got another 20 computers here. Hmm? Then all this 20 computer communicates to the other 20 computers. So totally, traffic of 40 computers need to pass through this section, the segment. So if I have just one link, not good. We need more bandwidth. So we can take like 6 links and aggregate them so that you will get more bandwidth, more throughput, more fast. And if one of the member of this bundle goes down, no problem. Few packets will be lost, and whatever the traffic that was going in this broken link now will be shifted to the other link automatically. Automatic. This is automatic. Likewise, the traffic from this link will fall back if this link gets recovered from the damage. If this link comes back again the load sharing will happen. So you have redundancy, you have increase in bandwidth, you have improvement in the performance, a lot of advantage. Ether channel, aggregation of links. Did you understand what we learned now? See the configuration that I was showing you, very simple, you see. Just you need to get into those two interfaces. You can see the name of the interface here. In your packet tracer, if you don't see this, it means you have not checked this one. Show the port labels. Always show the port. If this is unchecked, you see the names are not shown. Go to options, preference, and check this. Always show the port label. Now these two ports, I went into those two ports. Okay, and then I configure trunk, switch port mode trunk on those two ports. And then I said just one command, channel group. This number can be any number, but you need to make sure you give the same number on the other side. And then mode on. You need to repeat the same on the other switch. After that, you can come and verify. Show spanning tree. Usually it used to show 2 ports. Now you are seeing only 1 port because it's an aggregated one. What all interfaces aggregated as this channel that you can see by typing show ether channel summary. It shows that these 2 ports are in the bundle. Now you see, I'm going to add another port. See what happens. If I add another port, it is not a part of bundle. So there will be a block. Let's go and check. The newly added port is not a part of bundle. Show spanning tree. You can see the newly added port is in a blocking state. I'm going to combine this. I'm going to include this into the bundle. How to do that? Very simple. Go back again to the interface, the new interface, and put the same command switch port mode trunk, and then channel group, same group ID, mode on. That's it. Repeat the same on switch A. Interface F0/3, switch port mode trunk, channel group 1, mode on. Now let's go and verify. Show spanning tree. Look at this. The cost is still reduced to 9. Earlier it was 19, then it became 12. Now it has become 9 because the bandwidth is increased. Bandwidth is increased and it's shared. It's in a listening state. I'm waiting for this to become forward. Okay, forward. The cost is reduced much lower. I also check the same thing here. Show channel, show spanning tree. You can see even here it is forwarding. There also it's forwarding. Here also it's forwarding. Cost is 9. Now I would like to show you the members of the port channel. The command is show ether channel summary. These 3 ports are right now member of this bundle. Do you understand this? Can you do this? Do you have your packet tracer ready? What we have done is static port channel. We said channel group 1 mode on means statically you are turning on the port channel. We did static port channel. What we're going to learn next is dynamic port channel, meaning we'll use protocol like LACP, link aggregation protocol, or PAGP, port aggregation protocol, to negotiate. And when everything is clean on both sides, only then the port channel will come up. So that's more secured, more good than uh, this on mode. What we saw is on mode, there is no protocol involved, but when you include a protocol, it's more safe. Why? The port channel won't come up until all the hygienic things are in place on both sides. What do I mean by hygienic things? All those things that's supposed to be there configured, it will check. If it is there, then it will bring the port channel up. If not, it will be continuing as usual, individual links. We'll discuss more about this in our next class. 2 protocols, link aggregation protocol, LACP, and then PAGP, port aggregation protocol, the negotiation protocol for port channel. We'll cover in our next class.